Now we're going to talk about permutations with repeats. So sometimes the items in your group repeat, in which case the rule for finding the number of permutations changes slightly. So if we select n items without replacement, the number of different sequences or permutations can be found by dividing n factorial by n1 factorial and 2 factorial. So that's n1 factorial and 2 factorial. Those are going to be the number of times something is repeating. So we're going to do n factorial over n1 factorial and 2 factorial and so on. So we'll do some examples. So this first one says, how many different ways can we arrange the letters in the word keeper? So first we need to count the total number of letters. So there are 6 letters. So we're going to have 6 factorial divided by. Now K doesn't repeat at all, so we don't have to worry about that. We have 3 E's. So we're going to have over 3 factorial. And we can do this in our calculator by doing 6 factorial divided by 3 factorial. So we would have 120 different ways that we could arrange these letters. Okay, now we're going to look at the word Mississippi. So if we count, there's a total of 11 letters. So we're going to have 11 factorial. Now the M doesn't repeat, so we don't have to worry about that, but the I repeats 4 times. So we'll have over 4 factorial. And then the S's repeat 4 times, so we'll have another 4 factorial. And then the P's repeat twice, so 2 factorial. Now when we put this in our calculator, we're going to do 11 factorial divided by, and then we need parentheses around our entire denominator. 4 factorial, 4 factorial, 2 factorial. So we'll put that in. And we see that for the word Mississippi, there are 34,650 ways that we could rearrange those letters. So another way we could see this is number 3 says, a family has 5 children, 3 boys and 2 girls. How many different ways could they be born? So here we mean like boy, girl, or order. So you could have boy, 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 girl, girl. Or you could have boy, girl, boy, girl, boy. So here there's a total of 5 children, and we're repeating boys 3 times and girls 2 times. So we'd have 5 factorial over 3 factorial 2 factorial. So here there'd be 10 different ways for those for the genders to be born. So in all of the previous examples, we were talking about the way that things were ordered. The order mattered. But what if the order doesn't matter? What if you just want to pick a group of things, but you don't care how they're how they're ordered? So let's just say you had the words T, E, and A. So T, eat, and ate. Well, if you're talking about the way you can do the order of those letters, there are 3 different permutations. But if we just talk about the group of those letters, T, E, and A, this would actually just be 1 combination. So we're now going to talk about combinations. So when the order doesn't matter. So the combination rule, if we select R items without replacement from a group of n different items, the number of groups or combinations can be found by dividing n factorial by r factorial n minus r factorial. So this is NCR, and the formula is n factorial over r factorial n minus r factorial. And this is going to be smaller than the number of permutations. So we'll do it the same on the calculator. We can do it the same way that we did permutations. We're going to go to math, over to PRB, and this time it'll be choice 3. So when we have 5C5, our n is 5 and our r is 5. We're going to choose 5, hit math, go over to PRB, choose 3, put 5 in, and we'll see that this is just 1. If you have 5 objects and you want to know how many ways you can make a group of 5, there would just be one way. 4C3, we'll choose n would be 4 and r would be 3. So we'll have 4, and then we'll go over to probability. So this was 4. You can see these numbers are much smaller than permutations. And 22C5, our n is 22 and our r is 5. And this will give us 26,334. Okay, so here are some word problems you'll see that would let you know that you're using a combination. So number 4 says, we've decided to select a committee of 3 members from the statistics class. How many different possibility combinations of 3 students can you make from our class? So let's just assume there are 20 students in the class. So here, when we're talking about a committee, the committee, we don't care what order people are in the committee. We're not ranking them like president, vice president, or anything. They're just forming a group. So this is going to be a combination. So we're going to do 20C3. And here we'd see that there are 1,140 ways to do this. For our next problem, it says that 7 musicians are sitting at a table. 3 of them play saxophone. If you randomly choose 3 of the musicians, how many ways can you choose the 3 musicians who play saxophone? Okay. Now, to find the total number of groups of how many groups of 3 musicians you could pick, this would be 7C3. And this is a combination problem because the order that you pick these musicians doesn't matter. So we're going to find the total number of groups. So we would do 7 . So we'd get 35 groups. So the probability that you choose the ones who can play saxophone, well, there's only one group of 3 that plays saxophone. So it'd be 1 over 35. If you were choosing just one group, the probability of getting them, the exact group that all 3 of them play saxophone. Okay, so we're going to do some practice problems here. And here we're going to care about, does order matter or not? So are we doing permutations or combinations? So number 1 here says, a farmer has 10 trees, each a different species. How many ways can these trees be planted in a row? So since we want to plant all 10 trees and we're talking about the order, so this is a permutation. And since we're doing all of them, this is just going to be 10 factorial, which we can do on our calculator. So we'll have 3,628,800 ways that those trees could be planted. Okay, question 2 says a farmer has 10 trees, 5 maples, 3 oaks, and 2 buckeyes. How many ways can these trees be planted in a row based on what type they are? So this is a permutation with repeats, like we saw with the letters or with the boys versus girls for birth order. So there's a total of 10 factorial different trees. we're repeating maples 5 times, oaks 3 times, and buckeyes 2 times. And when you put this in your calculator, we're not going to do it to save a little bit of time here, but we would get 2,520. Just remember when you put it in your calculator to put parentheses around the denominator. Number 3 here says 7 people were in a race. How many different ways can we present awards for first, second, and third place? So here we're ordering 3 different people. So the order matters. So this is another permutation. And so there are 7 people and we're choosing 3 of them for first, second, and third place. So we're going to do 7 P3. So we'd get 210. So number 4 says find the probability of selecting 5 winning numbers from 1 through 27. Now we're not told that the numbers have to be in order, so we're going to assume that this is a combination. So there's 27 numbers and we're choosing 5 of them. So we'll do 27 C5. So we see that there are 80,730 ways. Now the probability of winning, if you're just picking one set of numbers, would be 1 over that number. So that would be our probability of winning. Okay. Number 5 says when testing for current in a cable with 7 color-coded wires, the wires need to be checked in pairs. How many different tests are required to check every possible pairing of 2 wires? This is another one that is going to be a combination. So we're picking 2 wires each time. So there's a total of 7 wires. We're choosing 2. So we're going to do 7 C2. So there are 21 different ways we could choose those wires. Okay, we have just 2 more problems we're going to look at. It's really one problem with 2 parts. So it says there are 12 members on the board of directors for a large company. So part A says if they must choose a chairperson and a secretary, how many different slates are possible? So they're choosing 2 positions, and those 2 positions mean we really care about the order. So the first one would be 12C2. Sorry, we care about the order. So it should be 12P2. So we're going to put that into our calculator. So there'd be 132 different slates here for those 2 positions. For part B, if they must form an ethics subcommittee of 4 members, how many different subcommittees are possible? So with committees, remember the order doesn't matter. So here we'll be using combinations. So we want 12C4. So that'll be 495 different committees they could put together. So just remember, with permutation, the order matters, or you're giving a ranking. With combination, you're just picking a group. The order doesn't matter.